This video is going to be going over variation of parameters, which is one of the methods you can use to solve a second order linear differential equation. The first thing that we will want to do is write the differential equation in standard form, and you'll want to find the associated homogeneous differential equation or the complementary function. We then need to find a linearly independent solution that would help us get associated with f of x. And so this is the process in which we are going to do this. You're going to take the determinant of y1 prime, y2 prime, or find the Wronskian. And since that won't be equal to 0, we then are going to find what we call Wronskian 1 and Wronskian 2. This is, we're going to incorporate f of x now into that equation or the Wronskian or linearly independent solutions with our y2, and then you're going to do the same thing with your y1. We'll then find some arbitrary functions that are based on Wronskian 1 and Wronskian 2. And then we can integrate those functions to find our u1 and our u2. Now, for the particular solution, notice that u1 and u2 is going to get multiplied by y1. So this is very similar to reduction of order, in that you're trying to find that variable or that function, u1 that is associated with y1 and u2 that's associated with y2. And then we have our general solution down here. All right, let's go ahead and look at an example. So the first thing we are going to do is find it's in standard form, perfect. So we're going to find the complementary function. I'm going to use an auxiliary equation of m squared minus 4m plus 4 equal to 0. I get factors m minus 2 and m minus 2. And so I have a repeated root of 2. That tells me that my complementary function must be c1 e to the 2x, and then for a linearly independent solution, it would be x e to the 2x. Now, if you notice, if I were to try to find this using undetermined coefficients, one thing that I might try to look at is a linear term times e to the 2x, but notice I wouldn't have any linearly independent solutions if I went that route. And so then another solution that we might look at is a quadratic times e to the 2x. And I could keep guessing and going and going and going. It actually turns out that this isn't going to work at all. We're not going to be able to solve for A, B, and C. So we would need to keep going. So this provides another method rather than the guess and check method for us to find our parts for YP. All right, so our Wronskian for our general solution is e to the 2x, x e to the 2x. And so I have 2 e to the 2x, and then derivative of the first times the second, plus the first times the derivative of the second. And I'm going to find the determinant here. So I get e to the 2x times e to the 2x plus 2x e to the 2x minus 2 e to the 2x times x e to the 2x. Now, when I distribute here, notice that that's the same term as this right here. So I end up getting just e to the 4x. So I'm only left with this piece, because this piece and this piece cancel. All right, so then let's look at how we would find our Wronskian 1. So we set this up by doing 0 and then f of x in place of my y1 and my y2. And then everything over here on the right-hand side stays the same. Now, I don't have to worry about that. I just need to say that this is negative x plus 1 e to the 2x times x e to the 2x. Again, when I distribute this out, so the negative comes from, right, this times this minus this times this, that's where that negative comes from. So I end up getting, let's do this, negative x e to the 2x minus e to the 2x, and I'm multiplying that by x e to the 2x. So I get negative x squared e to the 4x minus x e to the 4x. And then let's go ahead and find our u1 prime. So u1 prime is equal to, I'm going to move this piece down here. Give me just 1 second. Okay, that was going to be in the way. Okay, so I end up doing Wronskian 1 over our Wronskian. And so notice my e to the 4x cancel, and I'm left with negative x squared minus x. And so u1 must be the integral of that, or negative 1/3 x cubed minus 1/2 x squared. All right, let's go ahead and find Wronskian 2. So I do that exact same method, but this time I'm going to keep the first row and then do 0 and f of x here. Now this time when I multiply, this diagonal stays. And then I would get minus 0 here. And so, give me some more room here. I end up getting, let's see, this is e to the 4x, and then distribute. So I get x e to the 4x plus e to the 4x. And so u2 prime ends up being w2 over w, which gives me x plus 1. And so u2 must be 1/2 x squared plus x. All right, so let's now find our yp. So remember that's u1, y1 plus u2, y2. So x plus, negative 1/3 x cubed minus 1/2 x squared times y1, which is e to the 2x, plus u2 times x e to the 2x. Now we can distribute and combine some like terms. So notice here's an x cubed with an e to the 2x. When I distribute in here, I would have another x cubed e to the 2x. And so when I have negative 1/3 and then plus 1/2, I end up getting 1/6 as my coefficient in front of x cubed e to the 2x. And then I have an x squared here, and then I would have another x squared here. So I have a negative 1/2 and a 1. So plus 1/2 x squared e to the 2x. And so that's why I was saying x squared wasn't even going to work. We'd have to go all the way to a cubic, and I wouldn't have known to do that off the top of my head. So this method helps us do that. All right, we have time for one more example. In order to put this into standard form, I'm going to divide by 4. And then I'm going to see for my auxiliary equation, I end up getting plus or minus 3i. So my C1 e to the 0 cosine 3x, C2 e to the 0 sine 3x would be my complementary function. My overall Wronskian, I have y1 and y2. I take the derivative. And then once I take the determinant, I get 3 cosine squared of 3, oh, that should be a 3x, of 3x minus negative 3 sine squared of 3x, which ends up giving me 3. The reason is I factor out a 3, and then I would have cosine squared theta plus sine squared theta, which is 1. And so I get 3 times 1, which gives me 3. All right, let's do Wronskian 1. So in Wronskian 1, I put 0 and then f of x down here. And I end up with negative 1/4. Now cosecant is 1 over sine. So when I do that multiplication, I actually just get negative 1/4 and I'm done. So then u1 prime is Wronskian 1 over my overall Wronskian. And so u1 must be negative 1/12 x. All right, let's look at Wronskian number 2. I do cosine and its derivative. I do 0 and f of x. This time I'm going to get 1/4. Now cosine over sine is going to give me cotangent, not cosine, cotangent of 3x. And so when I go to do this, I get 1/4 cotangent 3x over 3. And the integral of cotangent, see I have 1/12 out here, is the natural log of sine 3x. Ooh, but there's a 3 here, so I actually need a 1/36. All right, so that tells me my particular solution is u1 times y1 plus u2 times y2. Now this is not a form that you would have known from undetermined coefficients, so there is times as well that variation of parameters would be the only method that you could use in order to find the particular solution.